Hi guys, in this part of the course we're going to be creating this cool looking sphere. Kind of looks like a Voronoi pattern that's been added on here. The main focus of this part of the course is actually applying modifiers, so creating modifiers for a piece of geometry and then applying it. So now we actually have this as geometry, so we could do cool things with it, even like I don't know, you could extrude it, make it look even more crazy. I don't know, you can experiment with this. We're just gonna be making the basic cube. Sorry, the basic sphere. We're actually gonna start off with a cube, so that's quite fun. Let's actually get straight into it. I'm just gonna create a new file and go to the scripting tab, create a new script by clicking the plus button here. Do our starting off steps, which is importing bpy and saving our script. So let's do Voronoi sphere course, whatever, you can call it whatever. Just make sure you save it to some place on disk. You can actually spam Control S like I'm doing all the time, so you don't lose your work. It's quite important. But yeah, let's actually create some work that we can save. The first step that I usually do when I create any script that generates any kind of geometry is I implement a cleaning of the scene function. So I usually just call this def clean scene. So you can call this function anything. So this is basically the function name, and this is the syntax of how you declare a function. So it would just be def function name brackets and a colon. Here you can pass arguments and all that fancy stuff. We're not going to be doing that now. We might do it in a different example of a function later. So we'll cover that, don't worry. But for now, we just want to create a basic function, call it clean scene, and then clean our scene. So in order to clean the scene, we're just going to grab every object in the bpy.data.objects collection. So this will return a list of all of the objects in the scene. So this will include cameras, lights, meshes, some more, but I think those are the main three that we have to care about. And then we can just remove that by doing bpy.data.objects.remove, and then just pass in the current object that we have in our loop. So if we were to execute this, spoiler alert, actually nothing's gonna happen because we have a function now, but this function is actually never called. So any code that is inside of a function declaration, so inside of this def block, we can see this is one indentation level over from whatever the declaration was. So all of this code is actually grouped inside of our function, and it will actually never be executed until our function is called. So if we were to call our function down here, which we can do like this, so we just specify our function name, and then we pass in our arguments through the brackets. So now there are no arguments, so we don't have to pass anything. If I were to run this now, our function would actually be executed. So that's how you do that. You can actually execute it multiple times by running. Just basically whenever I execute this line, I execute all of these lines that are inside of our function. So this is basically just a group of lines, and whenever you call the group, all of the lines inside will be executed. So that might be overcomplicating things, but if you just grab the core concept of a function in programming, basically this works the same. So now that we have our clean scene, so an empty scene here, we can actually start adding in our cool geometry. So the next bit of code, the next block of code I'm gonna call is create cool sphere, for example. Again, it doesn't really matter what you call these functions. Just make sure it's just at least a little descriptive. So you could argue that this is a little bit lame, a little bit not funny, or just not professional maybe. But it's just a fun project. It doesn't really matter as long as you know what it means. That should be fine. You're not going to be sharing this code anyway. But just general good practice is keep them readable, keep them descriptive, make sure you don't have to like figure out what they mean. But yeah, so when creating a cool sphere, we're gonna be having to do we're gonna have to do a couple steps, but let's not do them quite yet. So I'll just print generate cool sphere in here, because we need some kind of line of code in here in order to not break it. If I were to just run it like this, it would break because there's like no content inside. Even if I would fix my indentation, that's not actually the reason why it's breaking. So now it's actually working. What you could do, quick Python tip, when you want to already write like the architecture or like the code blocks of your script, but not the actual code in itself, you could write the pass. This is like a keyword in Python that is just gonna skip this basically. So this is preventing the error that you would get by declaring a function but not doing anything inside. So you can actually do pass. This is actually a bit better. What we're gonna do instead first is we're gonna create our cool sphere manually. So this is actually quite handy when you're starting off with this whole generating of geometry stuff. It's just doing it manually and see how it works, how you create the geometry manually, and then you can actually automate it, script it, make sure you can pump out thousands or tens of thousands of cool spheres without having to actually do it yourself. So let's make one and then script it so that we can make thousands. That's basically what I'm trying to say here. So in order to create a cool sphere, I'm going to start off with a cube because it wouldn't be very cool otherwise. Actually, the main reason I'm doing this is for the topology. I'll actually show you what I mean by turning this cube into a sphere by subdividing it. So we could add a couple more divisions to make it a bit clearer. What we have now is something that's kind of spherical. And if we were to add the cast modifier as well, we would have a perfect sphere with perfect topology if I were to turn that on as well to show you. Let's actually bump this down one time in order to show it a bit more clear. So I'm not sure how how familiar you are with topology, but you generally want to have quads, especially in visual effects and games. If it's just a still render, it doesn't matter that much. But if it has to deform or animate or anything, it's generally best practice to have all quads. You could also argue for all triangles, which is what you would get from an icosphere. If I were to turn the subdivisions up to 4 as well on this guy, and then we could compare them. You can see the topology is like not bad on this guy, like not at all. It's just all triangles, and you do have like a couple of poles. So if you're not quite sure what that is, this is just some topology. I don't want to say theory because that sounds dumb, but yeah, just generally best practice to have like a vertex with more than 4 input lines, and we have actually quite a lot there. I don't know, I just don't really like this types of spheres. I mean, all of the vertexes are evenly distributed, and they're all like, there are no n-gons or anything, but it's just, yeah, I don't know. Usually when you see like production wireframes and like breakdowns or anything, it's usually just quads like this. Like this would be a face, would work perfectly in rigging. It would deform perfectly, and this would just be a mess. I'm not sure if it's a lot of if it's gonna have a lot of impact doing it this way over this way in this specific course, or in order to create a specific cool looking sphere. But I just wanted to mention that this is usually the best way to create a sphere is by creating a cube, subdividing it, usually like, I don't know, 4 or 5 times. It depends how much your resolution you want, of course. And then applying the cast modifier. This cast modifier is actually essential as well, because this is gonna make sure that it's perfectly spherical. If I were to turn it off in the viewport, you could see, especially here, yeah, you could see it's not like perfectly round. It still has that cube shape in there, but if I were to turn this on, it's a perfect sphere. It's a perfect circle in all views. So all right, that's how you can create a sphere, but that's still not quite impressive. It's still not quite cool. The coolness we're actually gonna get by decimating it. It's just a single modifier, the decimation modifier. You might have used it before. This is basically to turn your high-res geometry and low-res geometry. So if you were to see it in action, you could see that we're actually taking the resolution away and we're getting closer to our icosphere look. But we're not gonna want to do it like this. This is actually quite nice if you want to like turn a high poly scan into a little bit less of a resolution, so your viewport and your GPU can actually handle it. But that's not what we're gonna be using it for. We're gonna actually set it to the planar type, and then we can play with the angle limit a little bit. So let's just up this so we can get nice planar surfaces. And then instead of wanting it to look like a puzzle, we want to look like actual planes. So we're already done. We have a cool looking sphere at this point. So all we have to do now is script it. Alright, so let's actually go in our code and kind of structure it a little bit. So when we create a cool looking sphere, we want to do a couple things. So we want to create a cube, we want to subdivide it, we want to cast, well, let's do spherify it, I don't know, I just apply cast, and then we want to decimate it. So this is how we can get the planar surfaces. So let's start off with the beginning. So we'll do cube equals create cube. We're gonna be using functions a lot through this course, because I know in the fundamentals course I didn't really bother with functions and code grouping. I just kind of put everything under each other, and that's perfectly fine. If you have like smaller scripts or just in general, that's perfectly fine. But I like to have everything split up in their own functions. This makes it a little bit more readable, semantic, maybe even if you're used to like HTML. It's always good to use semantic tags. But that's besides the point. I just like having it be more readable. So when I come back to this in a couple months or weeks, I can just really quickly glance over it. It's like, okay, so I clean it, I create the sphere. What do I do here? Just creating the cube. This is basically just making these comments obsolete. So I'll remove them later because they won't be necessary anymore, because it's just the code will be written in such a way that you can just read through it. And that's really valuable when you do programming in general. So that's just a little tip I want to give you. So when we do our create cube, we can write whatever code we need to create a cube, so we can just get it out here. That's also a tip I mentioned in the fundamentals one. So I can just create a cube and then go in here, look up what command was executed by Blender, and then just paste that in. So let's do that. Let me make it a little bit bigger for you guys, because I do want to stay zoomed in, because I know it can be quite hard to read text off like a video feed. So let's do something like this. I hope that's fine. We don't need much viewport space anyway. We actually don't need this either. So let's collapse that. We do need this. I'm gonna keep this open just to kind of copy paste back and forth. So we have a cube now. The size is 2. I'm actually gonna change that. Well, actually, how do I know the size is 2? Let me quickly show you. There is this thing called the Blender Python API, which is like the documentation of all of our bpy.whatever classes. So if we were to look cube add in here, we would get our function that we just put in. So primitive cube add, and if we were to look here, we would see there's a bunch of arguments that we can specify. So that's the same thing that I mentioned here, is that you have like these brackets, and inside you can add arguments which will be passed along through your functions or your groups of code. The cube add function actually has a bunch of these arguments, like enter edit mode, which we can see here and here as well. Enter edit mode. Now they actually have the same value, so you can see enter edit mode equals false. The way that this works is basically, it's like, oh yeah, they're already assigning it. Well, this is like a default value, so you're not obligated to specify enter edit mode, like the argument. If you don't override it, it will just default to false. So basically what we're saying here is just we're just repeating the default, so this is actually not gonna have any effect, so I'm just gonna get rid of that. Same with the location. So location equals 0, 0, 0. This is just a default, so we don't need that either. Unless, of course, we want to put our sphere in a different location. So if I were to put, let's say 10, 10, 0, 0, and I would execute this, we would see that our cube is created in the 10, 0, 0 spot here. But for this example, we actually not want to do that. The only thing we want to change is our size, and we want to put that to 1. I don't know why Blender defaults it to. Just weird to me. But yeah, you can just put it to 1 like this. So that works out. So we've created the cube now. One thing we notice is that we actually expect something to return. So I call this function, and then I actually assign this to like the cube variable. So since we use the brackets here, we will actually execute, this function, so this block of code up here. And then we assign it to a variable. So we're basically gonna need something to put in this variable slot. So we're gonna do that by returning something. So we can return anything, like an empty string or something. But in this case, we actually want to return our cube object. So what we could do is we could access this by doing bpy.context.object. So this will basically grab the currently active object, but it will be the object that was just created by our bpy.ops primitive cube add function. So this will essentially just yield the cube that was just created. We will return it, and then it will just be assigned to our cube variable down here. So if I were to print cube, go into our system console to watch this output, we would see that we have an object, and that is called cube. So here as well, you can see that cube down here. We always have this be called cube because we always remove the current object, like all of the objects in the scene, so it will just be cube since it's like the default name, I think, when you just add a cube. Maybe we can see this here actually, probably not. Well, doesn't really matter, just like the name doesn't matter anyway. So this will just return, this will just grab whatever object we just created and return it. And here we will just assign it to this cube variable. So at this point we can just refer to our cube with this cube variable. So that's all very convenient. So let's now actually get to the new stuff that we haven't seen before, which is applying our modifiers. So let's do it manually one more time so we can actually steal our little command down here. Subdivision surface, which is this guy here. Paste this in, and we can see again there is a bpy.ops method called. This is generally bad practice, so we don't usually want to use bpy.ops unless we want to like create geometry, which is just kind of the only way to do it is by using bpy.ops. But besides that, we generally don't want to use it. So one thing we could do is we could actually replace bpy.ops.object with our cube. So we don't have to refer to our active object anymore because it's now actually stored in this cube variable, since that's what we did up here. So what we could do is cube.modifiers .new, and then we could just specify our type in here. One more thing we need to do is specify a name attribute. So we'll just call this subdiv cube, whatever, and then we actually don't need this command anymore. So if I were to execute this, you would see, well, you wouldn't see anything really because this cube gets deleted and then the new cube gets added, and then it just looks the same because we had the modifier. So if we were to just remove this real quick to make it a bit more visually appealing, we get our cube, which has a subdivision modifier applied to it, which we can see here. Now the next thing we want to do is we want to increase the resolution. So let's actually increase resolution. It's just a bit like redundant, these comments here, but I just want it to be easy to follow. So if you don't want to type them over, you don't have to. So let's add a couple of divisions. Let's do 5. We can copy our command. Now again, we see bpy.context.object. So this is again referring to the current objects that we just have in our cube variable down here. So this is already better than using bpy.ops, but still, like, you don't necessarily have to have like such a long command. You could just simple it down by putting cube instead of this. One more thing we could do is we could actually replace this whole stuff, like this whole like grabbing of the modifier and that we want to access by just assigning it to our to a variable here. So we could say subdiv modifier equals, and then just this command to create a modifier. This will actually return the modifier that we just created. So this way we actually have this object here. So then we can just replace all of this with this to make it a bit more readable, maybe, because what we have before is like, sure, I grab a modifier that is assigned to the cube and it's called subdiv cube, but then if I were to change this, I would actually have to change this here as well, or I could create like another variable and put the name in there. But yeah, that's just annoying, right? So we can just assign our newly created modifier to this variable, and then we can just use that instead. So if we were to run this, we would get the cube. I'll just run it a couple times so you're sure. Actually, what we do now is we just remove all of the objects and then we create a new one, which looks the same as the previous one. So it looks like nothing happened, but when you see this line down here, you know that whatever you see in the viewport is the actual output of the script. So that's how you can verify that everything's working. All right, so now we have a subdivision modifier with 5 levels of resolution. Okay, so now that we know how to create a single modifier, we can basically just repeat the process for the other ones. So if you look here, we still don't have a perfect sphere, which we can fix by applying a cast modifier. So what we could do is we could just copy this line here. It's better than actually just assigning a cast modifier and then just copying it down here. We could use this still to get like the type of modifier, because yeah, it's not always exactly the same as we see here. Sometimes, I don't know, maybe this guy, yeah, multi-res instead of multi-resolution. That could be a bit hard to guess. I mean, it's quite obvious still, like kind of represents what it is, but still, if you don't know it. One thing you could also do is go into our Python API, and there is this bpy.types.modifier page. I'm actually gonna remove the highlighting. We don't want that. And then down here you have this type property. So that's actually the property that we set here. And then here you just have all of the possibilities. So you could see we have I'm just looking for one, but yeah, this is just all of them. You would have cast, so you could see how that is written. If you were to type multi-resolution, you would see multi-res. That's like the actual name that is used by Blender. So yeah, you could get it that way as well. It doesn't really matter. So we will spherify it down here. Just copy that. Call it cast modifier. Make sure the type is correct and the name is correct. So you can't actually have the same name twice. That's gonna conflict. So that's that. If you were to run this, I don't know if you saw it, but it turned a little bit more into a sphere. We can actually toggle it down here to see it more visually. I also showed it in the previous video, so this should be clear. And then lastly, we want to add our decimate modifier, so let's actually do that as well. Decimate, this is called decimate down here, so let's copy it, paste it, and then just make sure everything's correct. Decimate, boom, run that, make sure it works. So we have our decimation modifier as well. Now we want to do a couple things to this guy. So just like we set our levels in here, we can set all of these things in here as well. So let's set them manually. So we did 3 things. Now down here we see 3 things. 1, 2, 3. Earlier we saw that we can just replace all of this this grabbing of the modifier based on the name. We can just replace that by our actual modifier variable. Boom, boom, boom. And just like that, when we run our script now, just remove it to make it more visual, we will have our custom piece of geometry. So this will be our geometry with all of our cool modifiers applied to them. One thing to note as well is that we have to specify radians. In this case, you can see we can enter 20 degrees, but this is going to be converted to radians behind the scenes. So that's something you want to take into account. Allow me to go on a little bit of a side route and just quickly explain how we could put this in degrees instead of radians, because it might be a little bit just hard for people to wrap their minds around like 0.35 as an angle. It's kind of weird. Not a lot of people think in radians, at least I don't. So I just want to clarify for the non-math wizards like myself. So this is going to be a little bit of a recap from the fundamentals series. So if you didn't watch that, this is going to be quite helpful, I think. If you have watched it and you don't care about the Python interactive console, or you are a complete master of it, then you can just skip ahead. I'm just going to go quickly into what the interactive console is again and how we can use it to our advantage. So let me just quickly say what it is. So it is an isolated Python runtime where you can just execute commands. So this is just really simple. You could say print hello and you get instant feedback. So this is really good for single lines of code or like single blocks of code. So you could do for I in range of 10 print, this is print I. So like for really small blocks of code that's not reusable, well actually you could write a function in here and you could call it in the console, but then once you quit out of the console or you quit out of the session, you won't be able to access the function anymore. So it's just really, it's like a sandbox environment where you just do some testing, and then once your code is proven to work, you can just move it to the actual scripting view down here. So now you know what it is. Let's quickly go into how we can use it. So one thing I want to do is I want to figure out how I can turn degrees into radians without having to look up a formula and implement it myself. So one thing we could do is we could use the math package, or like the function library, which is, this just ships with Python. So let me quickly see what this gives you. Yeah, just everything. Let's not do that. So yes, math just ships with Python. So this is a built-in package. And we can use a bunch of things, like there's a bunch of things in here, so we can expose those by running the dir method with math passed inside. So this is basically all of the functions or properties that are inside of the math function library. So let's quickly show you one of these. So like how these work. So you see pi here, I could just do math.pi and that will work. One thing I could also do is like math.square root. Let's do the square root of 9 because that's an easy one, right? We can all know that. So this is just really easy to do, like basic math functions. We can just implement, we can just import math. It's really lightweight. It's not gonna make your program any slower or anything, so you don't have to worry about that. So one more thing that I see here that catches my eye is radians, because that's kind of what we want to do, right? So we could invoke the help method on it. So let's do help math.radians, and then we can see what this function is actually doing. So the built-in function radians in the module math, so this is the one that we want to target, and this basically converts an angle x from degrees to radians. So that's exactly what we want. It's not gonna be this easy every time. Sometimes you really have to dig through or like go into the documentation and find the method that you want to, or like the function that you want to use. In this case, we're lucky, so we can just do math.radians, and this expects an angle x. So you could see radians, and then there's like one argument down here, which is x, which is the angle. So let's say math.radians of 20 degrees is 0.3906, which is exactly what we have here. So we can just replace this odd number with this very readable, much better. Well, this is just personal preference. I just wanted to show you the console mainly. And I just think this is a bit more readable as well. One more thing we have to do to make this work is import math, because otherwise we won't be able to access this radians function inside of the math module. So even though this ships with Python and this is like a part of Blender even, you still have to import it, just like bpy. Like it's always going to be available. You don't have to install anything. You just kind of have to bring it into your script in order to use it. So That's just something that you cannot forget. Alright, so for the guys who just skipped ahead from the Python console for like the math thing that I wanted to explain, all we did is just replace our 0.35 with math.radians of 20. So yeah, if you skip that, just so that you're on the same level or on the same line, whatever, make sure you import math. Doesn't change anything about the output, just yeah, a little bit cleaner. Okay, so we're actually done. One thing we could do is we could apply these modifiers. So now that we have this stack, so it's non-destructive, we can actually chain this up, even though we've already generated this. You could limit this, so you could not have this be a thing by applying the modifiers. So let's quickly go into that, how you would do that. So I just did it on a random one just to get our command. So we could just use this down here. This is also a bpy.ops one. So not usually the best, but it's fine for now. Let's actually see if we can replace this with cube. We should be able to do that. Let's do it for all of them in order as well. Let's maybe actually put them after the actual creation of it. So let's so this is all the subdividing stuff. Then we have casting, and then we have decimating. So now it's all structured. So if you were to run this, yeah, it's not gonna work. This is actually gonna have to be bpy.ops.object then. I didn't think it was gonna work, but it was worth a shot, right? Whenever you can avoid bpy.ops, it's usually best practice to do so. And as you can see now in the cube, there is actually no modifiers anymore. So we can see they're all just baked into the object. If you were to, let's just not do it for the last one. We could see if we were to go into edit mode, we would still see the actual topology that we had before. Before the decimate modifier. So this is actually not applied, and now it is applied. So now we actually have this as polygons, as faces. So usually this is what we want. Also, like if you want to do insets, or if you want to continue modeling on the output of the script, then we're gonna need this. If we don't apply our modifiers, then this is not gonna work. So even though it is destructive, it does add new functionality, so it's something to think about. Maybe in your specific use case, you don't want to like collapse all of the modifiers. That's completely fine. I just wanted to show you how you did it. One thing to note is if you are using Blender 2.9, this syntax actually changed because they did a whole rework of the modifier panel down here. If you're using 2.9, you probably know by now. So you're gonna actually have to use a different command, which I'm gonna be typing out right now, which is bpy.ops.object dot modifier apply. So it's actually the same command, but all we need to do is specify our modifier and not our apply as, because this is like the actual thing that they changed. This is now like shape keys or something. Actually, I haven't used it myself. I do have an install of 2.9, so let's actually check this out. So if I were to run this here, that would be no problem. But if I were to actually, let's browse to it manually, because it'll just map to 2.81. It's the one I've been using the whole time. Blender Foundation 2.9. Blender X. Yeah, I was on my second screen. I'm sorry if you didn't follow. All right, so this is Blender 2.9 down here. Go to the scripting tab, new, just paste whatever we have. And if we were to run it here, we would get an error message. So if you were to toggle the console, you would see keyword apply as unrecognized. So you could see converting by args. If we could see the, yeah, here, line 23, which is this line exactly that I have. It is not recognizing apply as argument. So if you were to remove it here, let's not save it. we would see it still crashes, but now it crashes on the next apply. So it actually passed here. So if we were to look at the cube, we would see that our subdivision modifier is actually applied. So this works. So if we were to just remove apply as for every applying instance, run it now, we would see there's no errors. And it looks exactly the same. If I were to just turn wireframe on, boom. It's exactly the same. It's even a little bit cleaner, I think, in 2.9. I should be using 2.9. All of you guys should, man. Just keep updating Blender, man. They've been putting out so much like awesome new updates, and every version it just gets so much better. So I've been stuck on 2.81 for a while now. I should actually update. All right, I'm actually gonna stay in 2.9. Maybe I'll make the official change now and just stick with 2.9. But you might remember that at the beginning of this course I mentioned that I wanted to keep all of the code clean, and I started doing that, but then I just stopped doing it. Maybe one thing we could try is to clean this up. I want to give you guys the opportunity to try this out yourself. So basically what I want you to do is just group this code however you think is just optimal, however you would group it if you could choose. So just, you know, be free, check it out, how you can divide this up into smaller chunks of code, make it a bit more self-explanatory. Basically try to make the comments obsolete. So you see here, create a cube, and then you just call the function create cube. This comment doesn't have to be there, it's just redundant. So that's what you should try to achieve, is to not have to have any of these comments anymore. So if you want to try that out, now is the time. I will do it together with you guys right now. So if you want to try yourself, just pause the video. You can still come back. I'll just do it how I think it should be done. This is really not like set in stone, or this is not like an exact science. Just any way that you clean this up is perfectly fine. I'm just gonna show you how I do it if you're interested. So let's get to it. Last chance to pause or get out of the video. All right, so let's do subdivide, and then we will actually pass in a object to subdivide, because this way it's a bit more modular. We don't want to make cube a global variable, so this is actually already getting a bit more complex with functions. I'll quickly explain. So this is called the scope of a variable. You might have heard about this before. If you have, then it's just the same as in any other programming language. But if you haven't, the scope of a variable is basically the environment in which a variable exists. So since my cube is declared, so it's being assigned for the first time in this create cool sphere function, this means that my cube is gonna only exist inside of this function. So if I were to go like create a loop or create something else that is inside of the function, I will always be able to use the cube variable because it is accessible within the function. But if I were to try to access cube here, so if I were to do cube, like if I were to just copy this whole line, this is not going to work because cube is not going to be accessible in the subdivide function. Subdivide is not going to know what a cube is at this point because it's not been assigned. All it knows about is itself, so everything that is inside of this little code group, so nothing, because this is the first line, and all of the stuff that is outside of any function. So there's no cube that it can refer to, so this is not going to work. What you could do instead is use this argument down here, which is a way to actually pass one variable or a multitude of variables from one function to another. So what I could do is I could say subdivide, so I would call this function and I would pass in my cube. So this cube will then come in here and replace this object. So at this point, object will be equal to cube. But by doing it this way, we could actually, like down the line, we could create a sphere, a cylinder, or whatever, and then we can just subdivide it by passing in the object. So this becomes a bit more abstract, so it's less bound to a cube, because this is just subdividing. Subdividing has nothing to do with a cube. It is just taking in an object. So this is a rudimentary object, so that's how we can keep it abstract. We could also pass in a name attribute maybe to make it a bit more abstract, so we don't actually have to like subdiv cube, because we don't know it's a cube. It could be anything. And we also don't want to have duplicate naming, so if we were to call it again, well, actually Blender is going to handle this. If I were to call this function twice, the second one would just be .001, just like we do if we like duplicate an object. It will just get .001 added, so it will never actually be an exact copy of the name. It will just add a suffix to it, but we don't want this actually. We want to have control over the name. So let's put this in here, like so. There we go. So now we've actually replaced this line. Well, we still want to have access to it. Well, actually what we could do is we could actually just put the levels in here as well. And then we could say my subdiv modifier equals this, and then subdiv modifier.levels equals levels. So now we would do, so this is already in here, and now my levels is in here as well. So I can just add 5 here, and that would work. Now I don't have any more reference to this modifier in my create cool sphere function, because again, same issue with the cube, is that this is now bound to the scope of this function. So subdiv modifier is assigned for the first time at the subdivide function, meaning that it will only be accessible in the subdivide function. So if I were to try and like print subdiv modifier in here, it's not gonna work. If I were to print it in here, it is gonna work, because in here it knows what a subdiv modifier is, whereas here it has no clue. Like subdiv modifier, it's nowhere in the function, it's nowhere outside the function, so we don't know what that is. One more thing we could set here is like an apply boolean, and then we could say if apply, then I want to run this code, and instead of using the string we want to use the name. Boom. This way we have our subdivide function completely abstract, like this. Now what we could do, so moving on, we could set, we could create a function for spherification. So we do spherify. Actually, what you could do now is, so I've showed you one example, so I really want to stress again that you should try this yourself. This is a process that you really have to practice to make perfect. So I just showed it right now. The other two are going to be pretty much the same. So if you could try it yourself. There is one more optimization I'm going to make. So this is a little bit of a tricky one to see if you can figure it out. So it's still not just copy and pasting the first abstraction or like the first function. There is still one more step that you could figure out yourself. So I encourage you to try that out, to look for it a little bit. And then you can just come back here when you feel like it. So that said, let's continue. So let's do spherify. Actually gonna copy it here because I don't know how to write spherify. Lowercase it because that's just nicer in Blender. I'll just copy the arguments, but I don't want any levels here. I don't need that. Spherify. What we want to do now is we want to apply this to the object. Name equals name. So that's just the same like we do here. We can actually, well, there's no real need to keep track of the modifier object because we actually never use it. Cast modifier, it's never used again, so we don't really need it. The only thing I do need is this. If apply. So again, I don't just always want to apply. I want to give the user the freedom to either turn this on or off. So let's Let's put this in here. Just make sure that the name match. So this name should be equal to this name, which actually is not gonna be always the case. So if this name already exists, then this is gonna be .001. And then this is actually not gonna be .001. So this is gonna remove the initial one. So this might be a little bit abstract for you guys. I'm thinking if I should show you this in an example. I'm not sure this is gonna be very efficient, so I'm not gonna do that. We'll actually use a variable. So let's do cast modifier equals this, and then here we'll just do cast modifier.name, and we will do the same here. This way, if our name gets altered in any way by Blender behind the scenes, because we don't always have control, what we could do is we could check in like the list of modifiers to make sure that this name doesn't exist, and if it does, we could change it, and then we could put the changed name in here as well, which is just a lot of extra work. Basically what we do here is we create a new modifier, and we try to put whatever name that the user defined as the name of the modifier. If it didn't work, it didn't work, that's fine. The modifier is still going to be created. It's still going to be stored in this variable. And then basically using this property, this name property, we can just get the name of the current modifier. So the actual modifier, we can just get the name directly out of it. So we know that this is going to be the name of the newly created subdiv modifier, aka the subdiv modifier that was just created with this line. So if that's a bit abstract, I don't know, rewind and try watching it again. You can also just, what happened? Alright, typo. You can also just send me a message. I can maybe record like a separate video going a bit more into this, because it might be a bit unclear if you're not used to it. But okay, this should be a bit more bulletproof. So I do need this. I don't have to set any properties here. I just have to call it. So let's do sphere refi of the cube and call it cast cube. Apply, I want to do that. So let's do true. I probably have to do it here as well. So levels apply true. What you could do, like we saw it in the API docs, you could set a default value for all of them. Actually, let's actually do it for levels and for apply. So let's do levels to 3 and do apply to true. So this way, if we wouldn't do this, it wouldn't break. So I'll just do 5 because I want it to be quite high resolution. And here I just don't want to mention it. So let's put it here as well. So this way, if there's no apply in the calling of the function, it will just use the default. Do note that we do need to put any of these like default variables or like default arguments that have a default value assigned to them. We have to put them last. So you can't have apply equals true and then let's say like levels or something. This is not gonna work. So Blender, the text viewer is not going to give any issues with it, but when you try to run it, it will. So if you have like default assigning, always make sure that they run at the end. So no argument that has no default assigning comes after it. That's like the main thing I wanna stress here. But yeah, that shouldn't be a problem. Just try to follow this order. All right, so spherify we have, and then we want to do decimate a cube, and let's set the degrees. Let's pass in the degrees here to give some option. So decimate object name degrees apply equals true. Boom. Let's copy this because it looks more like this than it does looks like the cast modifier. So let's copy this. This is the actual command. So decimate name equals name. This will be decimate modifier. Boom. Well, we don't actually want to do this. if apply, I want to set my decimate modifier dot name. So I want to grab the decimate instance. This is the applying, so then I just need these three guys. Boom, decimate modifier, meta radiance decrease. Okay, so this is basically just moving code. I'm sorry if I'm not like talking much through it. Yeah, it's just moving. I'm actually gonna have to specify a name as well. Now you know that you might have noticed that I'm not running my code often, which is actually a mistake on my end. I should run this like every time I abstract into one function. I should run it and keep running it to make sure, because right now I could have broken something in the first function and I could have copied that mistake over, and now it's only 3, so that's not that bad. But if it's like 20, you really want to make sure that you do that, that you run it often. So actually, let's just try it, and of course, it doesn't work. Just like I said, I keep making my own mistakes. Subdiv modifier, yeah, that's not gonna work. Like so. Let's see if that worked. Hey, okay, so now it actually ran just fine. So one thing you might have noticed, so this is the extra mile that you could have gone if you would do this on your own, is I have a lot of similar code here. It's actually always the same. The only thing that changes is the name. So what I could do is I could abstract this as well. So I could create a function that is the apply modifier, and that just takes in a name. So I'll just pass as a placeholder, and then I just put the name here, and I would do apply, and then I would just apply modifier, and then I would just pass in the name of the current modifier. So current modifier dot name. This way, let's say down the line, or even when you want to switch this to 2.81 or 2.83 or 2.9, all you have to do is just change this apply modifier code once. So you could actually get the version of Blender, and then based on that you could either run this, or you could run the apply as, I think it was data. So this would, you would have to run this if you're 2.9, and you would have to run this in 2.8, but now you only have to specify this once. You only have to execute this command one. You only have to type this command one time. Sorry, you can execute it as many times as you want, but you only have to type it once. So let's say it changes over time, or actually you want to implement different logic to apply a modifier. You want to do something before it or after it or whatever. You don't have to go in here and do it like every time. Usually you only want to execute a command one time, like a proper bpy command. Of course, like a function, you might have to call it 10 times, 20 times if you can't do anything about it. What you could even do is I have like if apply the whole time. You could actually do that, check in the apply modifier, but that's kind of redundant as well. You could even create a method that says check modifier applying or whatever. This is really bad grammar or like words, but you could even do it like this, and then you don't need any of these if statements, and then you can just do the if statement once. Let me actually show you what I mean. Read this one more time. Make sure you pass the correct name. Could create a function def check modifier apply name, and then you can say if apply modifier name. So it looks so silly, I understand, but honestly, man, yeah, it just bad practice to repeat yourself. Even though it looks dumb, it's a lot more efficient down the line. So now I created this whole thing and it works, and then I spent like 10 minutes trying to make it more readable, and you could argue that that's like 10 minutes wasted because the program was working just fine 10 minutes ago. But yeah, taking this time might actually save you time later. So let's say you have to do this a bunch of times in the future. You can just come in here and copy paste this verify function, and this is just always gonna work. If you like, this whole structure now is just really procedural in a way. This is this can be called from different places with different objects. The way we had it before was really restricted to the current use case. So if this is the only use case that you're ever gonna have for modifiers, then you know, just fine, just leave it the way it was. But now this code becomes reusable, and it becomes easy to manage because there is no repetition in it. If you want to check modifier apply, if you want to change the logic in here, you only have to do it once, instead of before you would have to, in each of these guys, you would have to check it, change it, make sure it works. Whereas now you just have a centralized checking function, and you just do the checking in there, and it can't be any more obvious. You could also argue that, yeah, now you only have 3 modifiers, so it wouldn't take that much time to change it 3 times. But let's say you have like a complicated project. There's like, I don't know, 50 modifiers in there. Let's say you use like 10 of them even. This is 10 times a redundant change, or like a small change. It adds up in time, and just doing it properly directly. Like now I know I actually created it wrong first, and then it took me some time to make it right. But after a while you will just create it right the first time, and it will be easy to manage just from the start, just by default. So that's actually gonna save you a lot of time down the line. So I did want to stress that I mentioned that. So now we actually wrote a reusable tool that's gonna save us a lot of time in the future, and that's why we automate stuff, right? That's why we script, is to save us ourselves time. So you as a developer should save yourself some time as well, not just a modeler.